Hello and welcome to TechDaily.ai. I'm David.
And I'm Sophia.
You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, visit TechDaily.ai to get started today.
So I wanted to talk about a shift that's been happening in the industry. It's been pretty quiet, but it feels massive once you start to see it.
Okay.
We used to have this idea of the 10x engineer, this solitary genius who just churns out thousands of lines of code.
Right, the wizard in the tower. You slide a pizza under the door and 3 days later, a compiler comes out.
Exactly. But that whole archetype is, well, it's kind of dying, or at least its value is changing. We're seeing the rise of the product-minded engineer.
I hear that term a lot, especially in startup circles. It sometimes feels like code for, we want an engineer who also does the product manager's job.
It can feel that way, but I think the distinction is a little deeper. It's about moving from just knowing how to build something.
Which, let's be honest, AI is getting pretty good at.
Right. It's moving from the how to understanding what to build, and more importantly, why. It's about taking ownership of the outcome, not just the output.
Okay, but taking ownership can be a bit of a buzzword.
Yeah.
What does that actually look like for an engineer who's, bogged down in tickets and tech debt?
Well, this is where it gets really interesting. We've been looking at this book by Drew Hoskins, the product-minded engineer.
Right.
And he makes this argument that the real test of this mindset, it's not in the big flashy features.
Not in the launch party.
No. He says it's hidden in probably the most unsexy part of the entire code base.
Let me guess. Documentation. Or variable names.
You'd think so, right? But no.
Hmm.
Hoskins says if you really want to measure an engineer's product empathy, you need to look at their error messages.
Error messages. That feels so, low level. That's the stuff you write at 2 a.m. just to get the thing to compile.
And that's exactly the point. That's the moment where empathy usually just breaks down. But before we get into, the red text of doom, let's talk about Hoskins for a second. His background is pretty serious.
Oh, absolutely. He's not just some theorist. He was at Microsoft working on the C++ compiler backend.
Which is about as far from product fluff as you can possibly get.
Then Facebook on platform infrastructure, Oculus, Stripe, and now he's a product manager at Temporal. He's actually made the jump.
And that experience gives him a really unique perspective. He tells the story about the best product-minded engineer he ever worked with.
Yeah, this part surprised me. I was expecting some famous designer, maybe a visionary founder.
But he names John Carmack.
John Carmack.
Yeah.
The creator of Doom and Quake.
The very same.
Which is wild. When I think of Carmack, I think of, low-level optimization, binary space partitions, squeezing every last frame out of the hardware.
Totally. You don't equate rendering pipeline genius with empathetic product design.
Not at all.
But that's the paradox. Hoskins argues that Carmack's obsession with performance was a product feature. But he didn't just stop at the code. There's this great story from their time at Oculus.
Right. The platform was struggling. They had the headset, but no killer apps, no content.
A typical engineer might just say, hey, I built the SDK. It's business development's job to go get the apps.
Not my problem.
But Carmack didn't do that. He personally went to Netflix. He went to Mojang to get Minecraft. He sat down with their engineering teams and helped them port their apps to VR.
So he didn't just write the code. He actually bridged the gap to make sure the user has something to watch, something to do.
Exactly. He saw a user problem, we have no movies. And he used his engineering credibility to go and solve it. That's the product mindset. It's ignoring your job description to solve the user's problem.
Okay, I could see it with Carmack. But for the rest of us who aren't, convincing Netflix to rewrite their app, Hoskins brings it back to something we all touch every single day.
Diagnostics. He says diagnostics are the interface. And think about it. The last time you learned a new API, what was your main interaction with it?
Oh, it's a loop. I write some code, I run it, it explodes, and I spend the next 10 minutes reading the error message to figure out what I did wrong.
Precisely. For a developer, that error message is the UI. If it's bad, you're not just annoyed. You are completely blocked. But there's a much bigger implication here that Hoskins points out. Something that, honestly, it kind of terrified me.
This is the AI angle, right?
It is. We're moving into a world where more and more software is being written by autonomous agents.
So I give an AI a goal, and it just writes the code, executes it, and iterates until it works.
Right. Now, think about that loop. The agent takes an action, it gets an observation back, then it makes a correction. What happens if that observation, the error message, is vague?
The agent has to guess.
It guesses. It fails. It guesses again.
And since these agents are all billed by token usage,
You are literally burning money. If your API returns something went wrong, an AI agent might try 10 different things, burning through $1 of API credits, all because you didn't spend 5 minutes writing a better error string.
Wow, that reframes it completely. Bad error messages aren't just bad UX anymore. They are a direct financial liability.
Exactly. And to understand how to fix them, we first have to understand why they're so bad in the first place. He uses that classic example.
Oh, I know this one. PC load letter. The most hated phrase in any office in the 90s.
But why did it fail so badly?
Well, it's complete gibberish, isn't it? It sounds like it was randomly generated.
See, that's what we think, but to the engineer who wrote it, it was a perfectly precise, logical sentence.
How is that possible?
PC stood for paper cassette, the tray. Load was the verb, the action, and letter was the noun, the size of the paper, 8.5 by 11.
So the printer was just saying the paper cassette needs letter-size paper.
Logically, it's sound, but ontologically, it's a disaster.
Ontologically, that's a big word.
It just means the mental model of the world. The engineer's mental model has cassettes and paper socks. The user's mental model has the printer and regular paper. The message failed because it spoke the system's language, not the user's.
So the fix is to translate the ontology. Reload tray 2 with standard paper.
Bingo! But you can't just slap friendly text on everything. Hoskins says you have to categorize the error before you can write the message.
Right, the 5 categories. I'll admit, when I first saw this list, it felt a little academic. Do we really need 5 different ways to say it broke?
You absolutely do, because the right action depends entirely on who is at fault. So first, you have a system error. Database is down, network is out.
It's not you, it's me.
Exactly. The user can't fix it. The action is try again later. Then you have the user's invalid argument.
You typed the date in the wrong format. That's on you.
Yep. The action is fix your input. Then there's precondition, like trying to post a comment when you're not logged in.
The input's fine, but the state of the world is wrong.
Right. Fix the state. But then it gets into the trickier ones. Developer's invalid argument.
This is when my code calls your code incorrectly.
Yes. If one function calls another with a null when it shouldn't, that's a bug in the calling code. And finally, the last one is assertion.
That one sounds like the most serious.
It is. It means the internal logic of the function itself has failed. It's hit an impossible state. He uses the divide by zero example to show why this context is everything.
Oh yeah, this part really made it click for me. If I'm building a calculator app and a user tries to divide by 0, that's a user error, right?
Yes. It's a user's invalid argument. You tell them, hey, can't divide by 0. But what if you're writing a back-end service that calculates the average latency of your servers? You sum up all the latencies and divide by the number of requests.
And if there were 0 requests in that time window?
You get a divide by 0. But did the user do anything wrong?
No. The user just asked for the system status. The system itself failed to handle a perfectly valid edge case.
Exactly. That is an assertion failure. If you show the user math error, divide by 0, they'll be completely baffled. The error needs to be logged for the dev, and the user should just see no data available right now.
It all comes down to asking who can fix this. And if the answer isn't the user, don't scream technical details at them.
Which brings us to that great channels case study.
Yeah, the fictional Slack-like app. So the user wants to send a message to a channel called Barnyard Friends.
Right, but channels are supposed to start with a hash, like hashtag Barnyard Friends. The user types at Barnyard Friends.
And the system just throws back. Cannot deliver to channel at Barnyard Friends.
Yeah.
Channel does not exist.
Okay, so I'm going to play devil's advocate for a second. That error message is 100% factually correct. That channel name literally does not exist. Why is that bad?
It's bad because it's lazy. It makes the user debug your system's data model. They're sitting there thinking, I'm looking right at the channel, I spelled it correctly. Why is the computer telling me I'm wrong?
You're forcing them to do all the work. Hoskins calls this the search space.
The space of all possible solutions.
Yeah. Yes. And a good product-minded error message collapses that space. The improved message is, channel at Barnyard Friends is prefixed with at TOA. Did you mean hashtag Barnyard Friends?
That's a night and day difference.
Yeah.
You're not just reporting a failure, you're guiding the recovery.
There was an even better example, the Chicken Little one for on-call alerting.
Oh, right. The site's on fire, and you try to page the on-call engineer at Goosey Lucy.
But at Goosey Lucy left the company last month. The standard error is just user not found.
Which is a total nightmare. You're in a panic, the server is down, and the system just tells you, nope, that person doesn't exist. Good luck.
A product-minded error anticipates the user's real goal. The goal wasn't to find that specific person, it was to find whoever's on call. So the better message is, user at Goosey Lucy does not exist. To fix this, update your on-call rotation here with a link.
It gives you the next best action. It turns a dead end into a doorway. But let's talk about how you actually implement that. Because the low-level database code that says user not found has no idea you were trying to send a page alert. It just knows a row was missing from a table.
This is where architecture becomes critical. He talks about raising errors at the interface boundary.
So the low-level code knows the what user ID was not found. But the high-level code, the interface, knows the why we were trying to page the on-call engineer.
And you have to combine that knowledge. You can't just wallow the technical error because then your developers can't debug it. This is where he brings up chaining exceptions.
This is like the from error clause in Python.
Exactly. It's a translation layer. You catch the low-level key error, which means nothing to a user, and you re-raise it as a high-level on-call user not found error that has a helpful message. The full technical stack trace is still there in the logs for the dev, but the UI gets something a human can actually act on.
You're serving two different audiences at the same time.
But, the best error message of all is the one you never have to see.
The one that's prevented from happening in the first place.
Right. He calls this shifting left, catching errors as early as humanly possible.
I love the laundromat analogy he used for this.
It's so perfect. You don't go to a laundromat, put all your clothes in the washer, add the soap, pay for it, wait an hour, and then check if any of the dryers are working.
No, because then you're just stuck with a pile of wet clothes. You check the dryers first.
And that's upfront validation in software. Don't start a huge multi-step process if you can tell from the start that the final step is going to fail. Check the destination before you leave.
It seems so obvious, but systems get this wrong all the time.
Another huge piece of shifting left is using fakes, and Stripe is the gold standard here.
Oh, their test mode is a work of art.
It's brilliant. They give you a list of fake credit card numbers that are designed to trigger specific, predictable errors.
Right. Like if you use the card ending in 9995, it will always fail with an insufficient funds error.
Now think about what that enables. As a developer building on Stripe, how would you normally test your insufficient funds user experience? You can't just drain your own bank account to make sure a red box shows up.
It would be a very expensive way to find a bug.
So by providing these fakes, Stripe lets you test the sad path just as easily as the happy path. They are handing you the tools to be a product-minded engineer.
There was one other technique that I thought was really smart, especially for complex systems, the idea of dry runs.
Or user confirmations, yeah.
Yeah.
This is for anything with major consequences. Like, imagine a user is setting up a retry policy for a bot.
And they messed up the timing.
Yeah.
They accidentally set it to retry every 10 milliseconds, forever.
That's basically a self-inflicted denial of service attack waiting to happen. A bad system would just save that config and then fall over later. A product-minded system calculates the impact before saving.
And the UI says, whoa, this policy will result in 60,000 requests per minute. Are you sure?
It models the future and warns the user. It protects the user from themselves, and it protects the platform from the user.
This really changes the definition of what done means for a feature. You're not done when the code works. You're done when the user can't mess it up. Or if they do, they know exactly how to fix it.
That's the whole message. Empathy isn't some soft skill you bolt on at the end. It's a technical requirement baked into the architecture.
So for everyone listening, engineers, product managers, anyone who uses software, what's the big takeaway?
I think it's that we have to stop treating errors as an afterthought. They are a core part of the product. And as we talked about at the beginning, the users of the future aren't just going to be people.
Let's circle back to that AI agent idea.
If we keep building software with lazy, cryptic error messages, we're building a world where those AI agents just can't work efficiently. We are creating an artificial ceiling on the capability of AI.
That is a heavy thought. We could be bottlenecking the entire future of automation because we couldn't be bothered to write a clear sentence.
So the question is, are we building software that will starve the AI, or are we building software that will teach it? The product-minded engineer is building for the latter.
Well, that is definitely something to think about the next time I see a something went wrong pop up. A huge thank you to Drew Hoskins for all the insights in the product-minded engineer.
It's a fantastic read.
And thank you to everyone for listening. If you enjoyed this, check out TechDaily.ai for more. We'll see you next time.